So, starting on number 4, we're going to see this. It gives us this cubic equation, or this cubic polynomial rather, and it wants us to find all the roots. This is really similar to number 3. Okay, you'll see up here, the only difference is that this gives you a factor and this doesn't. If this one gives you a factor, all you have to do is go in and synthetic divide, but on this one, there's nothing to divide by. Like, you don't really know of anything to divide by. That's when you know that you have to do factor by, you have to factor by grouping, okay? And what that means is, you're gonna write your cubic out here. And it's just in the name. So for the grouping part, what that means is, you're going to make the first two a group and the second two a group. Okay? Let's bring out what the first group has in common. Well, x cubed and x squared, they've got x squared in common, along with x plus 7. And then if I bring this out, I can factor out a 5 here, and both of these have a positive 5 in common. A positive 5 in common. So if I factor that out, that's 5x. 35 divided by 5 is going to give me 7. And what you'll notice here is you have two things. You have what you factored out in front, and then you have these two parentheses of what you have left over. If you did it right on factoring by grouping, these should always be the same. So I have two sets of x plus 7s. Okay? So that means these x squareds are going to come up front. X squared plus 5. Like this guy right here and this guy right here are going to make my first group. So this is where the factoring part comes in. And so x squared plus 5, and then I've got x plus 7. Okay, so I grouped them. So I grouped, and then I factored, and I'm left with this. Okay, and just like normal, this is a little bit different of a method, but to get roots, that's what it wants, is all we have to do is set them equal to 0 and solve. X squared plus 5 equals 0, minus 5, minus 5. I'm left with x squared equals negative 5. To get rid of the squared, I take the square root on both sides, and I have x equals, that negative means I'm going to have an I, like I'm always going to have a plus or minus with my square root. That negative means I'm going to have an I, and on this, the square root of 5 doesn't simplify, so I'm just going to write I square root of 5. So plus or minus I square root of 5. And then here, we just know that if you can write it out if you want to, but when it's an easy one like this, all you got to do is flip the signs. So x equals negative 7. So one of my roots is going to be negative 7, and I'm going to put that here because remember, rational means that you're going to have like a normal number. I'm trying to think of the best way to describe it. It's a normal number. Okay, imaginary roots means you're going to have an I, and irrational means you're going to have an ugly decimal, or square root, but you can there's no I in it. So if I look at I've already taken care of this one. If I look at this other root, it's got an I in it, so it goes right here. So plus or minus, and notice what it says. You can put plus or minus for this. So I squared of 5. And then do I have any irrational roots? Well, I've already taken care of 1, 2, 3. I've got my 3 roots taken care of, so there's 0 irrational roots. Okay. So right here, all you would do is, like when you're given this equation, you're going to list the roots and draw a possible graph. What I need to know is that you know this. X squared plus 7 minus 4 squared plus 8. So when I look at this, am I able to tell where the roots are? Yep. So this is going to be the opposite. So negative 7 is going to be one of my roots. I can go ahead and write that. Negative 7. And my multiplicity is given there, 2. This, positive 4. So one of my roots is positive 4, multiplicity of 2. Then I've got plus 8, so negative 8. And there's nothing here, so that's just a 1. So negative 8 and 1. Now, what's weird here is that it asks for a y-intercept. So remember, x and y-intercepts happen when x is equal to 0. And I made this one more challenging on purpose. Like on the test, you would have a y-intercept that fits on the graph most likely. Like it's not going to be this ugly. But just to show you and give you a little bit more challenge and so the test is easier, this is what I did. So you take this, you take your equation. So I've got x plus 7 squared, x minus 4 squared, and x plus 8. And it happens when x is equal to 0, so I'm going to have 0 plus 7 squared, 0 minus 4 squared, and 0 plus 8. And you can type that in your calculator just like this, or go piece by piece. And this is going to give me 49, 16, and 8. Like I said, this y-intercept is really, really ugly. Don't get me wrong. Like, this y-intercept is super ugly. But don't get super lost in that. So I'm actually going to need my calculator for that. So let's see here. 49, 16. There's not a calculator on this thing. Okay. 49 times 16. We can do some old school math here. 49, 16. That's 24. Like I said, this is a huge number, so like, don't get super lost in this. On the test, I promise it won't be that big. Um, 56. So right here, my y-intercept would happen at 62, 72. Obviously, I mean, that's going to be like way up here on the graph, like way, way, way up. But on the test, you might have something like 9, and it would fit on a lot nicer. So what would happen, like the most important part is what would happen at 8? Well, I know that it's going to cross because the multiplicity is 1. At 7, like at 7, it's going to bounce, and it's going to do something else. Boom. Oh, wait, why are you doing that? It's going to bounce, and then come over here. Like, it would go way up. Cross, bounce, and here. Okay. And that looks wonky. On the test, it'll be a lot easier. I made this one hard on purpose. So, going to 6. Given this, find all the roots. Once again, this is a different kind of factoring that we've not done in a little bit. So this is called difference of perfect squares. Number 6, difference of perfect squares. And if you need practice with these, just Google this name, like difference of perfect squares, Khan Academy, and it'll walk you through that skill a little bit more. So right here, all I'm doing is taking x squared minus 64, what I'm given, and I'm going to take the square root of both, okay? I'm going to have a plus and minus always, plus and minus. Take the square root of the first part. Well, that's going to give me x in front, because the square root of x squared is x. Let me do a different color here. And then right here, the square root of 64. Just ignore the minus. Just tells you that it's a perfect squares, and I can do this. Don't get super caught up in all that. But what I have here is take the square root of 64, and I'm going to have 8 and 8. So I've got x, oh, and this is x to the 4th, sorry. My bad. X to the 4th minus 64. So that's going to give me x squared here, because the square root of x to the 4th is x squared. I was a little bit ahead of myself there. Once again, I'm trying to hurry and get this to you all before the deadline at 9 a.m. So x to the 4th, take the square root of that, and I've got x squared in front on both, okay? So I went from here to here. Take the square root of the front, it breaks into groups of x squared, take the square root of the back, and it gives you that. So, on the test, it's going to work out perfectly, okay? Like you're not going to have one where you have to do the SOX method, so don't get super stressed out here. But for this sake, all you got to do still, regardless of what number you're given, always when you're finding roots and you have your factors, set them equal to 0. Minus 8 minus 8. X squared equals negative 8. Take the square root, okay? So x squared equals, always going to have that plus or minus. So 8 is going to break down into 2 and 4 and 2 and 2. So I've got 2 2's, so a 2 comes out. Because of the negative right here, I'm going to have an I, and I've got a square root of 2 left. So plus or minus 2i square root of 2. And here, same, very similar result, but you're not going to end up with a imaginary number, because you're taking the square root of a positive number. You're just going to have x squared equals 2 square root of 2. So let's go through what we got here. So on this one, this underlined in purple, I've got plus or minus 2i square root of 2. There should be a plus or minus here too, plus or minus. And for the I, I'm going to have plus or minus 2i square root of 2. Remember, anytime you have an I, it's automatically imaginary, okay? And then here comes an irrational part. So my plus or minus right here, that I just underlined. So plus or minus 2 square root of 2, I've got that right here. That's an irrational root because of the square root. Remember, the square root with no I. So 2 square root of 2. Because if you type that in your calculator, you're probably going to have something similar to like 2 point, I'm trying to think off the top of my head, like 8.5 and a bunch of ugly decimals with no pattern. So that tells you it's irrational. And I have 0 rational roots. Okay? Last one on this video, and then we'll break it up into a third one. It says write an equation for the function that has roots of 5, -3, and -2, all with a multiplicity of 1 and a leading coefficient of 3. Let's start with the stuff that we know. So for the factored form, that's the really easy part, right? All I'm doing here is writing it out. I've got x plus 5 x. And wait, what mistake did Mr. Hampton just make? Pause for a second. Think about it. Okay, hopefully you've had time to think about it. Right here. Why does it need to be x minus 5 instead? That's halfway a trick and halfway Mr. Hampton messed up. But right here, x minus 5, because it's factored form. So going from roots to factors, you always flip the sign. So instead of -3, I'm going to have +3. And instead of -2, I'm going to have +2. And what's it say the leading coefficient is here? My leading coefficient is 3. So all that's a fancy way to say is the number in front is 3. That's easy, right? Like flip the factors and then put the number out front. The leading coefficient is 3. So to go to standard form, you just write it out and multiply it in. Okay, what I would recommend doing, go ahead and multiply that first one in here, and it just goes like that 3 into the first thing. So 3x minus 15, x plus 3, x plus 2. Now, what's important here is now you've just got to do the box method twice. So, combine these, got 3x squared minus 6x, just making sure my math's right, minus 45, and then I've got x plus 2 to multiply by. I'll do that in blue. So I got 3x squared, 6x minus 45, x plus 2. So multiplying these out, 3x cubed minus 6x squared minus 45x. And then I've got 6x squared. Multiplying to get in the boxes, 12x, negative 12x, and minus 90. So combining across diagonals here, my standard form. So my standard form here is going to be 3x cubed. Look what happens with the x squareds. They cancel out, so I don't need any of those. Boom. Then I've got negative 45 plus negative 12 gives me negative 57x minus 90.